Okay, good morning, everyone. Can you give a thumbs up or send a message in the chat just to confirm that you can hear and see me? Great. Okay, so a pleasant day to everyone. I'm Renette Roy Thomas, CADRIM Coordinator, and I have the distinct pleasure to introduce you to today's guest speaker for our webinar focused on the impacts of climate change in small island developing states, with a specific emphasis on the Caribbean. Hi, Ronald, if it's okay, if the participants can just mute their microphone when the presentation is being delivered, just so that we can reduce any external noise. Thanks so much. So today we'll be having Mr. Jayaka J. Campbell, who's a Senior Research Fellow within the Department of Physics at the University of the West Indies at the Mona campus, where he teaches physics and engineering courses. He's also a member of the Climate Studies group at that campus and has been actively working with that group to produce groundbreaking climate change and climate modeling work for the past 10 years. Jay is a researcher and an innovator whose research interests include climate variability, climate change and climate modeling, renewable energy, the Internet of Things, engineering solutions, hardware and software design. He's one of the foremost climate change modeling experts in the Caribbean and has worked on a number of climate change projects within Jamaica and the wider Caribbean. He has authored and co-authored several journal articles and technical reports, and he's currently pursuing his PhD at UE, the Mona campus. So Jay, thank you so much for joining us today. Before I hand over to you though, I'd like to just advise participants that all questions should be posted in the webinar discussion forum within the e-learning platform, and Jay will be available to respond to you between today and Friday of this week. The WebEx chat box here should therefore be limited to just advising us if you're experiencing any difficulties in viewing the presentation or hearing the presenters. So with that said, I'm very happy to pass the mic over to Jay. And thanks again, Jay. Over to you.
Good morning, one and all. I hope you're hearing me, and if you're not hearing me, let me know, and I will actually work from there. So this morning we hope to have a very quick conversation about climate change, and this morning we're going to actually focus on the Caribbean, its past, present, and what about its future. All right. In order to do that, we're going to actually do two things. We're going to actually do a quick review of the story of global warming, how it happens, linked to climate change. We're going to look at the impact and consequence of climate change, and we're going to do this from a global perspective and work our way down to the Caribbean perspective and detail a little bit about society's response. All right. So thinking about it, and when you think about it, the background you had was basically from a point of view of, you know, the natural effect. Without this naturally occurring greenhouse effect, you know, the Earth would be a frigid wasteland. The naturally occurring greenhouse effect is a good thing. It allows the sun's radiation to come in, the heat is re-radiated, some of it is trapped, keeping the Earth warm and livable, right? And when we talk about that, we're talking about that, you can imagine that being a greenhouse or a car parked in the sun, where it's parked in the sun and the windows are up. You know, you leave it 15, 20 minutes, you go back, it's warmer than the externals. Right? And another way to imagine this is, and as I like telling my students, imagine you're in bed and you are sitting, it's cold outside, and you've found yourself under a blanket. You found yourself under that ideal spot under the blanket where it's not too hot, not too cold. That spot where you feel as if you're melting into the bed. You don't even want to wiggle your toes or your nose. That's the Earth with the naturally occurring greenhouse effect. However, right? And when we talk about the greenhouse gases, we're talking about carbon dioxide, methane, chlorofluorocarbons, ozone, and nitrous oxide, right? However, there's a point at which, because of man's activity, because of urbanization, deforestation, and largely primarily through man's fuel-intensive activities, that blanket becomes a little bit thicker. If you take yourself back to the realm where you're lying in bed under a single blanket, and that's ideal spot. What happens if people toss more blankets on top of you? Invariably start getting warmer. So that's the Earth with the human enhanced greenhouse effect. That blanket becomes a little bit thicker or a little bit more concentrated, so it traps more and more heat. So if you compare the two diagrams, you realize that more and more heat is trapped, less is allowed to escape in the human enhanced greenhouse effect. All right? As I said, it's a very brief review because I'm sure you'd have covered this in greater detail at some point. So, human activity, there are several ways in which the Earth's climate can change. There is due to natural variation, which is due to its position around the sun. It can change due to volcanic eruptions. But for this part, this period, we're only focusing on human activity. When we talk about human activity, there are many activities that actually give off greenhouse gases, from the industrial processes to the power stations, waste disposal, land use and burning of biomass, residential and commercial activities, and the color coding actually indicates as well the gases that are given off. So 72% of our activities give off carbon dioxide. All right? Now, who is responsible? It's this question that's been, tossed around. If you look at it in a perspective in terms of total emissions, you'd expect that the larger countries, the more developed countries, or those that are at the point of burgeoning to being first world countries, would have been the largest emitters. So, the darker colors mean the persons who are giving off more. They'd expect the US and China and India to be the ones that are well above the world's average, and that's the case. However, when you look at it in a per capita sense, the picture changes. So China falls to being at the world's average. The US ends up being above the world's average. And to drive this point home, I have taken the liberty of putting another slide there. And it gives you the same kind of information, but in terms of a footprint. The size of the circle in the total emission indicates the amount of emissions, the biggest emitters. When you look at it in a per capita sense, what you find out in a per capita sense is that the Caribbean, who happens to be in blue, right beside the US, ends up taking up a larger amount of space and the larger circle. So you realize US Virgin Islands now, in a per capita sense, when you divide your total emissions by their population, they end up being one of the biggest emitters. So we, within the Caribbean, although we're small, a lot of our activities don't happen to be fuel efficient or happen to be in the sense that we want them to be climate sensitive or climate smart. All right? Now, without further ado, we're going to actually say, one of the key points to drive home is that when you observe, you take globally average temperatures and you examine them from 1850 to 2015, all right? You have the warmest year on record being 2016. That beats 2015, which was the warmest year on record. And then that eclipsed 2014. So over the past few years, we've seen that we've entered a new regime where every year we've actually been facing has been warmer than any year we faced before. And this is data taken from the Met Service, NASA, and NOAA. And this is when you're comparing them to a difference from 1961 to 1990 average, all right? And NASA even went further to report that 15 of the warmest, 15 of the 16 warmest years we've faced on record, and this is the 2016, have all occurred since 2001. This means that in some context, we've entered a new regime, all right? But people can argue, what does warmer mean? Well, we take 1 year, a single year, a single realization, and we examine that single realization. And we look at that single realization. You can, for selected events in 2015, you can see that within the Eastern Pacific, at the end of August, there are 3 storms. This represented the first simultaneous occurrence of 3 major hurricanes in that basin since 1949. All right? Mexico had several heavy precipitation events in 2015, and right across the globe, there are instances of things that have never occurred before, and this is just with us selecting the year of 2015. All right, we can take the step further and look at significant climate events. In December 2015, in Alaska, it tied its 1968 fourth driest December since records began in 1925. So at every point over the last couple of years, we've been beating every single record that has ever been set in a climate sense. All right. Now, in a more sensitive way, we can actually look at it from a perspective that, in terms of temperature, we can see that temperature anomalies when you compare 1940 to 1980 means. We can see that almost everywhere on the globe, barring very, very few places, has gotten warmer between about 0.5 to 1.5 degrees. All right. So between 0.5 and 1.5 degrees. We can do the same thing for precipitation. And when we look at precipitation or rainfall, there are a few things we note. All right. One of the things we note when you're looking at rainfall is that annual precipitation trends, there's no distinct drying across the globe. Some areas are getting drier, some areas are getting drier more significantly than others, while some areas are getting wetter, and some areas are getting wetter, more precipitation. Some areas are getting in excess of 40 to 50% increase when you compare that trend. Right? So there's no overall drying trend, but right throughout the tropics there seems to be this drying trend. Overall, sea level rise. Globally, we've seen sea level rise. You know, when you're looking at it, you've seen about a 20 millimeter, 15 to 20 millimeter sea level rise since 1994. All right, I can do the same thing for coral reefs, and there's this interesting thing about corals is that they're very sensitive, and they provide so much such benefits. However, they're extremely sensitive, right? They can't run, they can't move. They live in a very narrow band or narrow depth of water. And they're extremely sensitive, as I said before. They're temperature sensitive, and they're sensitive to changes in the quality, or how to put it another way, the cleanliness of the environment in which they live. Now, as we said, we've seen 2015, and this record is to 2015, right? In 1998 and 2015, we've seen 3 mass global events, where in some instances, a third of, reef extent has been bleached between 2010 and 2015. And once they're bleached, that's it. We've lost a lot of biodiversity there. Not to say that it can't recover, but if our record temperatures and the temperatures keep going, there's not a time for them to recover at any point in time. All right. Now we come to the meat of the matter, and the meat of the matter is what's happening regionally. Regionally, right, studies within the region have suggested that since the 1960s, right, the Caribbean has experienced an average 22 warmer days. Right. So whereas it used to be the case that you had your warm days, and then you used to be able to get some respite at night, where you would, you'd be able to turn your AC or your fan on or crack a window until probably 12, 1 o'clock. And at between 1 and 2, it would have gotten too cold for you to keep the window open or keep the fan on. You'd have to turn it off. Now the case that we've not just our warm days have increased, but our warm nights have increased. So overall, the temperature range between our daytime temperatures and our nighttime temperatures is shrinking, which means that overall we're getting hotter. So it's no longer the case that you turn your fan on or your AC on and you turn it off at 1 or 2 o'clock. You leave it running almost consistently because you need some bit of respite from the heat. And it's not just within what we deem to be our summer months that we're seeing increases in temperature. We're also seeing increases in temperature in our cold nights, in our winter months. So we've seen fewer cold nights. So guess what? Summers are getting warmer, and what would be deemed to be that Christmas breeze or Christmas period or winter is also getting warmer. So overall, within the Caribbean, we're seeing this extent where the days you have that are supposed to be cold days or cold nights are decreasing, and the days you have that are supposed to be, warm days have increased. And a measure of your warm day is basically taking you're looking at the days that are at the 95th percentile, so which means that these are extreme days, and they're actually increasing. All right? We did the same thing for rainfall. And the beauty about rainfall is this. The wonderful thing we realized about rainfall was this. All right? Although we couldn't say anything about the totals, right? We couldn't say anything about the totals because the totals tended to remain the same. What we could say was that the periods between our rain events have been increasing. And if the periods between your rain events have been increasing, but your totals haven't changed, it means that when rain does occur, it means you're getting enough to make up for those periods those days that you'd have missed rain. So when rain does occur, it happens to be more intense. So you get longer spells of dry, but when rain falls, it happens to be more heavy. This tends to lead to an increase in flood events, and it's kind of a wonderful spin-off. All right? Now, when you examine hurricanes, there's this, I could leave this image here, and the number of lines could actually say what's happening. And we compare the period of 1981 to 2000 and 2001 to 2016. And I've distilled this diagram into a better slide. Please note I'm not counting any of the storms we faced in 2017. I'm not counting any of the storms we faced in 2017. All right? Now, when you look at the category of storms and the totals for a period of 2001 to 2016, which still 4 more years left to go, and 4 more years left to account for, we've seen 20 more tropical storms to hurricanes, 20 more, right? We've also seen that we've seen more Category 5s. We've seen twice as many Category 5s. In fact, we've seen twice as many, and we haven't counted anything for 2017 yet. In Category 4, we've seen an increase, and there tends to be this relative normalcy at the end. And this was suggested that by future research, which I'll cover, that when we do face storms in the future, what will happen is that they can't say anything about the numbers, but the intensity is what is going to change. And for the Caribbean, if you look at the Caribbean as a whole, right, every sector within the Caribbean is vulnerable to climate, be it agriculture, tourism. So imagine a single event, devastating a region like that. And what we've also seen is that whereas the case you used to get 1 storm every 10 to 12 years, it's now the case that a recovery period of 10 years doesn't exist anymore. So you may get 2 storms in a year or 2 storms in a 5-year period. And if you take the case of Grenada, where Grenada is known as the Spice Isle, when Grenada got impacted by Ivan, right, all nutmeg trees on Grenada laid flat. And if you know nothing about nutmeg, take this. Before nutmeg gets to the point of bearing fruit, it takes 10 years. Now imagine the entire crop, an entire nation being devastated by a single event, and their GDP is almost set back by 10 years because for 10 years, it can't produce any nutmeg. And this would be an occurrence that happens not just once every 10 to 15 years, but no, on a more frequent basis. All right? Extreme weather events, and here we're examining flood events. So we went through recordings in newspapers of flood events, and this is actually examining a case in Jamaica. And we went through newspapers where any record of flooding was given. And what we realized was that, the latter 20 years of the period we examined was 49% more active than the previous 40. If in the previous 40 we had 100, in the latter 20 we had 150 flood events. All right. So we've seen temperatures are increasing. We've seen rainfall that's more variable, and also rainfall that's more intense. We've also seen more extreme weather events, not just talking about storms. We're talking about floods, and we're talking about droughts. All right? The Caribbean sea level rise is at the rate of the global mean. And here I've picked out some points across the Caribbean, and I've also picked out what's happening at Port Royal, highlighting Port Royal, and it's well within the global mean. all right? So what about our future? When we take climate models and marry them with scenarios, or take computers and you do a computer model to actually simulate what's going to happen with future climate. And this is from work done within the Caribbean. What we are seeing is that across irrespective of the scenario used, and this is using an A2 and a B2 scenario, and we can do the same thing for the RCP scenarios because there's a relationship between A2 and B2 and RCP scenarios. In the worst case, right, or even in a better or best case, the Caribbean warming between, the difference between 1961 and 2009 and between about the end of the century is anywhere between 1 and 3.5 degrees, right? The warming is consistent with what we see in the globe, and the warming exceeds natural variability. This means that exceeding natural variability, there's something else that must be used to account for the rate or the level of warming we're seeing. All right. Another telling picture we can use to drive this point home is this: our temperatures are still increasing. If we take our historical temperature means and then use our projected temperature ranges from the A2, A1B, and B1 scenarios, there comes a point by the mid-2020s where every year in the mean that the Caribbean will face will be warmer than the hottest year we felt to date. All right? Some argue that this is somewhat of a climate departure, where if your coolest day in the future is warmer than the hottest day in your past, that is kind of like a climate departure, where your nighttime temperatures would be then equivalent to your past daytime temperatures. All right? When we project into the end of the century, 30, depending on where in the Caribbean you look at, 30 to 98% of your days annually will be considered to be hot days. And only 2% of those days by the 2080s will be considered to be cool days. All right? Again, rainfall will still be variable. So you're looking at rainfall becoming more sporadic. So the distance between your rainfall events is now more sporadic. Adding that sporadic nature to rainfall, and you're adding a drying trend. So imagine the rainfall events are now spaced. Well, add that fact that you're expecting a 25 to 30% drying, right? Where the drying is within the months that you're supposed to be getting your rainfall, between that June to October period, that period that coincides with when storms occur, all right? And it's suggesting that, remember we said right now, even though the Caribbean has gone through a period of drought in 2010, 2012, 2015, Caribbean has gone through a drought that superimposed on that a 25% drying trend. All right, and you can get the point we're driving around. All right. For storms, the number of simulated storms remain the same. All right. However, what we can say definitively is that they have higher rainfall rates and increased maximum wind speed, which means that when storms do form, they tend to get to a stronger intensity. All right. I'm going to take a case from Jamaica for sea level rise, where under 1 meter sea level rise, under 2 meter sea level rise, 1% of Jamaica's land area will be lost. Jamaica has 3 airports, 2 on the north coast, 1 on the south coast. 60% of the airports will be lost or damaged. When you look at the island context, within the island context, there are a few things that happen. One, between 50 to 70% of the population lives between the 0 to 10 degree contour, which means that they all tend to live within a coastal region. All right? 100% of Jamaica's port structures will be lost. All right? And I can take it to another island. I can take it to the Bahamas. You can look at under 1, 0.5, 1 meter, 2 meter, 3 meter sea level rise. Right? 22% of the population will be affected at risk of flooding. And annual loss to GDP by 2050 will be up almost, 950 million. And if you go to the 2080s, it increases to 2.6 billion. And that's just from the threat of sea level rise. We've not included the threat from storm damage. We've not included the threat from storm surge. Right? We can actually go to the Eastern Caribbean and look at Antigua under 1 meter sea level rise, 12% of the population will be at risk, 100% of the airports will be at risk of flooding, and 50% of the hotel resorts would be threatened. All right? Now, as I said to you before, every sector within the Caribbean happens to be climate sensitive. If you're talking about health, you're talking about the vector-borne diseases and persons who actually have respiratory illnesses. Agriculture, you have crop yields, irrigation demand, pest management. You have forestry impact, you have water resources impact, you have coastal areas, and you have impacts on wildlife. When we tend to think about climate change, we tend to only think about what affects human beings, all right? And key to note is that the gender of reptiles is largely tends to be dependent on temperature, which means if temperatures increase beyond a particular threshold, you know, it may sound, I can extrapolate, and the extrapolation may be very simple. You could very well end up where reptiles end up for, if they're hatching a particular temperature, all having the same gender, right? All right. So society's response was Kyoto Protocol, and it failed to achieve its target. Major nations such as US and China were back and forth at each other, and as such it failed to achieve its target. You had the Copenhagen Accord, and it ended in acrimony because of lack of agreement again. And the Paris Agreement, which, you know, was thought to be, you know, a global initiative because it had, you know, from the onset, within year 1 or 2, it had gotten the amount to be of consignees to be ratified. And even with the pulling out of the U.S., or the attempts to pull out by the U.S., people have still gotten the message that something has to be done. All right? And now, at the end, I want you to think about this. The Caribbean and small island states are pushing for 1.5 to stay alive. The Paris Agreement pushes for 2 degrees and says the world can achieve 2 degrees by the end of the century. But what does this mean for the Caribbean? All right, one study done out of Suriname, done by Peter Nong, suggests that, and it's looking at hydrology and river recharge, and so looking at what can be generated from hydropower and what recharge would be. Suggests that at 2 degrees, all right, the recharge, the rainfall that will be yielded from 2 degrees will not be sufficient enough to recharge river supplies. It's done. And that's just one study. There are several other studies, one looking at health, some looking at the overall climate. What does it mean? What's the difference? At 0.5 degrees, what does it mean? And if we go back to the difference we can go back 2 slides to what happens for the Bahamas. You can look at the yellow line versus the red line. And even at a 0.5, between a difference between a 0.5 and a 1 meter sea level rise, it's quite telling. All right. Now, there are 2 main policies that can be used, right? And, you know, and they're large and overarching, and they're mitigation and adaptation. And you may think that, you know, there's very little that we in the Caribbean can do. There's a lot we can do. We can actually change consumer behavior, all right? And one of the biggest things to do is, the hardest thing to do is to change consumer behavior. So once you do anything that looks at reducing the amount of emission of greenhouse gases, that's a mitigative effort. So you can actually employ new technologies and renewable energy, and you're making more older equipment more efficient. So that per capita map I showed at the start, where the Caribbean happens to be, on a per capita basis, some of the biggest emitters. If we change out older equipment, change consumer behavior, and in some instances, even if you look at removing the single-use plastics, you're changing consumer behavior, and that affects overall what happens. All right? Changing consumer behavior means also protecting carbon sinks, you know, like forests and oceans, and creating green areas. All right? And my final slide before I end this presentation, right on time at 30 minutes and leave it open to some discussion, is that the thought of adaptation. where we're using scarce resources more efficiently, building natural defenses like dikes. But sometimes these in and of themselves are not an adequate measure. Because I can give you the example of Guyana, where the capital city of Guyana is below sea level. And, you know, if it rains too heavily, you don't even have to have that. The pumps can't manage the volume of water to pump it out, so the city will flood. And setting aside a land corridor to help species migrate. All right, I was given 30 minutes for this presentation, and I believe I have taken about 25, and I'm more than open and ready to entertain your questions.
Hi, Jay. Thank you so much for that excellent and informative presentation. I myself learned quite a bit. I have no doubt that everyone will be generating a lot of discussion in the forum. Just first, on behalf of the Reference Center, CADRAM, as well as the Red Cross, Red Crescent Climate Center, and the participants, I'd like to thank you for, imparting your knowledge with us today, and look forward to your continued collaboration throughout this module and beyond. The group of persons connected live are quite small, but if anyone would like to pose any burning questions right now, please do so. And if not, please remember that the webinar discussion forum in the platform is open to everyone now to post comments and questions. And as I mentioned before, Jay will be available over the next couple of days to respond to any questions that you have. So are there any questions that you may have for Jay at this time? Persons might be a little shy to speak at the moment, but persons are quite communicative in the forum, that's for sure. So at this time, Jay, thank you so much. Thanks to everyone who logged on to connect. We really enjoyed the presentation, Jay, and we look forward to your feedback over the next couple of days. A great day to everybody, and we'll be in touch soon.
Thank you for having me, by the way.
Of course, our pleasure. Thank you. Take care, everybody. Bye-bye.